Howdy folks, I'm Mark. I make stuff, and today we're going to be talking about this thing that I made, a production-ready serverless API built to manage scores and leaderboards for web games. And through this process, we're going to be touching on loads of AWS services, such as APIGateway, DynamoDB, and Lambda functions. And we'll use the serverless framework to deploy all this lovely stuff for us on our AWS VPC. First, some background on this project. Back in the early 2000s, I used to make loads of Flash games, and some of them weren't even terrible. How's that for a weird brag? In those days, I stored scores and leaderboards using a simple PHP script running on a VPS. A decade or two later, those Flash games are gone, but I do have some web games that I've made. I need a scores API, and the old PHP script isn't going to cut it anymore. Mostly because I just don't want to pay for an always-on MySQL or Postgres instance to store those things. A simple serverless API using DynamoDB might just do the trick. On a side note, I made all that Flash stuff for a website called ridiculopathy.com. Don't bother trying to learn how to spell it or pronounce it. I pulled all those games off long ago when Flash died. RIP. Now it's just a portfolio site for some of my weirder projects, like a social media platform where you can only post colors, or a space shooter I made for Steam where your only weapon is a ping pong cannon. You know, that kind of thing. You can tell that I have a love of impractical things, but today we're talking about something very practical. In fact, this project is in production right now, storing and displaying scores for a React game I made last year called Figure 5 Frenzy. The link to it is in the what's-its below. All right, enough expository monologue. Let's get into this. So the first thing we need to do is install serverless globally. And we would do that with npm i g serverless, right? So we're in our project directory, so we're going to start the project by saying SLS. SLS is an alias for serverless, so we don't have to type that every time. Serverless create template AWS Node.js, and we'll give it a name. And what that did was that gave us a handler and a YAML, right? So this YAML is a lot of commented out code because it's there just to be an example. You can see the handler here is very simple. This is basically sort of a hello world. So we're going to start with the service name. We'll give it that, why not? And framework version 2, we'll leave that. So provider is AWS, which is correct, and we're going to say node 14x. We'll leave that Lambda hash version, and we'll say the stage. This may not be completely necessary, but it's helpful to give you an idea of how these string literals work in YAMLs. So we'd say option stage or dev. So what this means is this stage property on the provider will be equal to the stage property when we deploy, or dev if it's not provided. The region so we're just setting a global default for our API gateway to set cores true. Which is pretty straightforward. And now we're going to get to the fun part. We're going to get to functions. Whenever we define these things in serverless, we're giving it a logical name, and then we give it a name that it will appear in AWS. So this is our logical name, and we're going to call this MMS Scores API. In this case, we're going to give it an AWS name that's going to use this stage value, right? So we're going to say SLS stage. So it's going to use this value up here, I believe. So we're going to say SLS stage, and then we'll call it MMS Scores API. You know what? We're going to call it Lambda. MMS Scores Lambda. That's fine. And the handler, we could use the handler.js the way we have it, but what I'd prefer to do is have a folder called functions And then we'll rename that something that makes sense to us, API scores, right? And we'll put that inside functions. And so our handler will be functions / API scores handler. So that's what will connect, triggering this Lambda to this code. The role is going to be something we're going to create later on. And this is an IAM role that AWS needs to be able to see if this Lambda has access to certain resources in your VPC. In our case, we need two things. We need a role that gives you access to CloudWatch logs so you can create log events for debugging. And we need to be able to have access to DynamoDB because that's where we're going to save our data in two different tables. So we'll call this MMS scores Lambda role, API Lambda role. That seems descriptive enough. Events. Right? Now we're defining basically how APIGateway is going to connect requests to this Lambda, right? So we're saying HTTP and path is API. You're going to be given an endpoint, and it'll be endpoint and then /API. Method. We'll use any for now. We're going to be using get and post, so you'll be getting scores and posting scores, but we'll say any for now. So cores, we're going to say origin star, meaning these scores are going to be coming from games that live on the web, and we don't always control where that IP is coming from, right? The service is going to check for the source IP to authenticate the request. So if another server is asking to store a score for a particular game, this will say, nope, we're not going to allow that. It's only from allowed IPs. And the headers that we're allowing, content type, so we can say, hey, we're sending you a JSON string. We're going to allow the API key. And last fetch key. This will become more apparent how we're using this later on, but the way DynamoDB thinks in terms of how it presents data to you, you'll be doing a load more pagination as opposed to page 1, page 2, page 3. DynamoDB doesn't really think that way. It thinks of what was the last key you received. When you load more, it's going to load results past that key. So and we're saying you are not going to allow credentials. So we're not allowing logged in endpoints for this Lambda, which is good because you can't have both. You can't have the origin star and allow credentials true. It seems like that's not advisable. And that makes sense when you think about it. So if I'm having credentials coming in from the outside world, I better know what server that's coming from. That is the Lambda definition. And so the next thing we do, we go to resources, checking to make sure my alignment is right. And then we have resources with a capital R. So we're going to have a couple of DynamoDB tables we're going to define here. We're going to call this MMS scores API type is AWS : DynamoDB : table. So that's a syntax that you see quite often in this. So we're going to say properties table name. Okay. SLS stage. Just as we did up here, we say SLS stage. So we're going to give it a name that will tell us what stage we're in. So we'll call this MMS scores. And then we have attribute. We're going to define some attributes. And these attributes are going to be used to define the key for this table as well as the indexes. The way DynamoDB thinks, it thinks in terms of partition keys, which are similar but not the same as a primary key. In SQL, you just have an integer or a hash that represents your primary key. No other row in that table can use that same item, right? It has to be unique. In DynamoDB, you use partition keys, and those are a little different. So a partition key in this case describes a field or a combination of fields that describe exactly where an item can be found in the database. One of the great things about DynamoDB is it is scalable to a ridiculous degree, right? It's horizontally scalable all the livelong day. But that also means we have to be highly specific about how we address things. So in this case, we're going to say score ID. This is going to be our main partition key. Now I said S here. You can pretty much guess that that means string, and you would be right? So we're saying the type of this score ID is string because it's going to be a hash. Same thing for game ID. Now I'm using lowercase field names. It's very common for folks to use uppercase field names here too. I just tend to not do that. So N in this case stands for number. So our score is stored as a number. So when we send the scores to DynamoDB, we're going to parse that integer or that float to make sure that that stays a number. So those are our attribute definitions, and now we're going to describe our key schema. In this case, we have a compound key schema. We have an attribute similar to what we had before. Attribute name, score ID, and our key type is hash. So that's what we expect, right? So that's what you would think of as a primary key, in this case, a partition key. But we have another key, and it does something very interesting. We're using the score itself, and we're using it as a range key. That range key tells DynamoDB how we want things sorted. What's really nice about this is that the sorting is sort of baked into the table itself. And that can be really helpful for results that update quickly, and you're doing load more pagination, things like that, to make sure that you're going to get results that make sense. But one thing to bear in mind, if I wanted to go in and delete a score, well, if you do that, you need to provide both the score ID and the score. Even though that score ID is unique, it doesn't matter. It needs to be both. And that's one of the things that you have to bear in mind when you're working with DynamoDB. One of the biggest frustrations that people have with DynamoDB is that, and myself included, constantly thinking about DynamoDB as a drop-in replacement for SQL, or more likely for Mongo. That we're thinking of it like, oh, well, it's going to do these things for me. It's going to return these results. It doesn't really think that way. Another thing that DynamoDB doesn't like to do is query on non-indexed fields. When I want to return scores for a game, I'm not going to be returning all the scores that are in the table. I'm going to return all the scores for a specific game ID. Well, to do that, I need to create a global secondary index so that it knows to create a copy of this table that is oriented around the game ID and not oriented around the score ID. And one thing you need to be careful about, you can end up adding a lot of secondary global indexes, and if you do that, it can make your database more expensive in the long run. So you want to be careful and kind of judicious about how to set that up. The next step is setting up those global secondary indexes. So we're going to create index name, and we'll call this game ID index, and we will add a key schema for that. So we're saying we're creating a secondary index where game ID is going to be the primary item. In fact, what we could do is just take this. Right, so this is going to be a copy of this table where we're focusing on game ID, so we can query on it very quickly. Go back to this, and then we're going to say projection. So projection the projection property tells AWS how we want to copy this index from this table. So we're saying we want to project everything. Now, if this was a very big table, we would want to be a little more judicious about projecting. In our case, it's a small table, a small number of fields in the table, doesn't matter that much. But in production for a very large project, this would be something to really think about. We also want to do a couple of things here. We want to add our provision throughput. Our read units, we'll set that as 5. Now, we could dial that up and down depending on our needs. But you'll notice I'm going to repeat this because let's say we got rid of that. The next thing on our list after key schema would be to add the provision throughput. But in this case, we're putting the global secondary indexes in there, and you can kind of see that it's the same information. And this gives us a lot of granularity over how much capacity we want to have. Maybe this index we want more capacity for this than we want for this, because it's not that common that we're going to be looking up the raw table. It's much more common that we're going to be using this index. So maybe this would have 5 and this would have 1. I don't know. It just depends on how you want to do it. If you have a different idea about this, let me know in the comments. Let's add a comment here and just say table scores. And then we'll create another one down here and call it games. So some of this can be copy and pasted. In fact, I'm just going to do that. But okay, so we have that, and we'll change this to games, game ID. Well, this one's going to be a little different. We're going to, instead of looking on the game ID, we're going to be looking on the API key. So API key index. And we don't need that. And we don't need that. So similar to the other one, very similar. We have one global secondary index where we're using this to look up games by the API key. So the API key is going to come in from the outside world. We're going to use that to check on that. Okay, so the role is pretty complicated. So I am going to just copy and paste it in here from another document. You have to keep everything in the correct tab order. If something is like there, for example, it's not going to see it. So that's a concern. What did we call our role? We called it that. And so we're going to call it that. So this basically we're creating an IAM role. There's the name, and we reference that in the Lambda. This is boilerplate policy document stuff. We're assuming the role, that's all good. We're also allowing log groups, creating log groups. So these are the big things that we want the Lambda to be able to do with CloudWatch. Also, we want the Lambda to be able to have certain database operations that they have rights to. So we have put item and query, and I don't think we need particle select. Particle is really neat. It's a SQL-like syntax for DynamoDB. It's pretty great. We're not really using it in this project, so we don't really need that. But one thing to bear in mind, you can get lulled into a bit of a false sense of security with Particle because it looks like you can query on any field you want, but in fact, the strictures of DynamoDB still exist even if you're using Particle. So you have to bear that in mind. So a couple of more things to add. First thing we're going to do is, we can delete all of this stuff, can't we? So we'll delete everything but outputs. But the most important thing we need to do so we're registering this serverless offline plugin that we haven't installed yet, but I'll show you what that looks like. So in our outputs, this is what we're going to see after we deploy. We can run a command called SLS info verbose, and that will give us everything from our output. So in our case, let's say we wanted the ARN for our DynamoDB tables. I'm going to copy and paste some of the stuff in here, but that will output that for us. I don't think we need anything else there. So that probably has loads of bugs in it, and that's fine. We'll get to those. We'll fix those. But that's the basic operations. You see, it's only like, it's less than 150 lines, even though we do have some items that are kind of lengthy. It's pretty great. We are going to create an npm init, and we're going to create the project. So we're just going to say, yep. And then we're going to go npm ID, meaning we're saving these for development only. These are dependencies you wouldn't need in production. They're both going to be pretty obvious why they're not. Serverless offline and AWS SDK. So the AWS SDK obviously is baked into the AWS service, and serverless offline, obviously, we only need for local development. So you can see that we have our two dev dependencies here, and we're going to see if we can deploy dev. It probably will not like this. I see what it didn't like was that I had copy and pasted in from an earlier version of this project, and that kind of thing can only land you in trouble. These resource references down here were referencing old versions of these table names. It also looks like I'm using the AWS name instead of the logical name here, and that's an easy enough fix. And so now it is complete. And there's our dev endpoint that we can use. So if we wanted to see the output of the deploy based on those items up there, then we would just say SLS info verbose, right? If we go to DynamoDB, we can now see that we have these tables. So those tables that we provisioned that say dev MMS games, dev MMS scores, those now exist. The partition keys are there, and we even have the sort key, and we have our index. So let's see in items, we can see games and scores, and we're going to create a game. And I have some UUIDs I have already generated. So that's a string. We'll create a new value that is going to be the name, and we'll call this test game 1. And we'll create another one. That's a string. We'll call that API key. And this will be a really long value because why not? And then we will create a Boolean that is active. Is it active? And we'll say, yeah, it is. So there's our game. We'll create another game too, because it's always helpful to have 2 of these games just to make sure there's no crosstalk. Use that as our game ID. We'll create an API key, another long one, right? And then we'll create a Boolean active and set it to true for now, and we might disable it down the road. But those are our 2 games, and so we can just go into the AWS console and do that. One thing that we might do down the road is extend this with an admin panel. So we're not going to add scores directly here. These are going to be coming in through the API. This gives us what we need to be able to get started. We are going to run SLS offline and get this running locally. There we go. So it's just telling us it's running locally. So we're pulling in the AWS SDK and we're creating our DynamoDB client. You notice because we're in the cloud and because we're connected to AWS and we're connected to our VPC, we don't have to worry about database passwords and any of the secret management stuff. This is all happening for us within the AWS ecosystem, which is pretty great. We're going to use a different syntax here. We're going to say exports handler equals async event. We won't be using context, but we want to make a place for it. And callback. Now, callback is what we're going to return when we return our results. So if we have a problem, we'll say return callback, and we'll give it like a 400 error. Another thing we need to do is we need to go back to our game definitions, and we need to add a new field that I forgot about. And this one is called allowed IPs. So using camel case, we wouldn't be cat P on that. So allowed IPs. And we'll just have that for now. Right. And that's only for local development. Once we're in prod, it won't know what to do with that, but that's fine. The first thing we're going to do in this function is we are going to get the source IP from the event and request context identity source IP. Right, so that's going to tell us who's there. Now we're using optional chaining, so we have to make sure that we're running on node 14. That's why I specified node 14 when we started this project. We're going to say method. We're looking for the event method. We'll switch the method and we'll do a get. And this is for get scores. We'll put a break in. We'll put a break in here for now, but eventually we won't need the break because we'll be returning, right? Post and break. So what we're going to do is we are going to run a local get scores and post scores in Postman. So in this case, we're saying dev API, so that information's correct. We're sending the API key, right? Game 1, and we're going to grab the API key. All right. And this won't do anything right now, but we can actually do like a simple console log, and we'd say source IP and method. We just want to make sure that we're actually getting what we think we're getting. You can see we have the source IP and the method right there. So we could say console log so like, I get it, that's a bad pun. So we run that and it'll give us the bad pun. We're going to get the API key. So let's get the API key up here because I think we're going to need it in both functions. We're going to say const. We're going to destructure that. X API key is how it's going to come over. And so we're going to call that API key. And we're getting that from event headers. And let's check API key as well. So this is going to pull it in from the event. Oh, it's undefined. Interesting. I had API key as one word. And there we go. And we also need to get the stage. Deconstruct these like that. And then, right? And then we should be able to see everything now. And that says dev. We're going to create a helper function that's going to grab the game ID based on the API key. Right? So get game ID from API key. And we'll have some inputs and we'll export it. And then we will import it here from helpers, right? So we are, before we get into the method and start doing things, we're going to say game ID equals get game ID from that, and we'll say await, and we're going to feed it the information that it needs. So first off, we're going to send the API key, we're going to send the stage, and we're going to send that DynamoDB client. And we're just going to send that there. So at this point, we're going to query that secondary index we created on the games, the API key index. We're going to query that index against the API key that we're providing. So we're going to say return await DDB query table name and like that. So that's our table name. Index name API key index. Scan index forward. We don't care about that. Key condition expression. So we're going to set the key condition expression to API key equals API key. So that's basically a where statement. We're using this to parameterize it, right? So we're saying expression attribute values. And we do our replacements, right? And then we attach a promise, and then we say then we grab the data from that query, and we say, okay, const game equals data items 0, meaning the first item off the array. Notice that items is uppercase. Many of the reserved words having to do with DynamoDB are uppercase, so bear that in mind. We could destructure game into the values that we need to make some evaluations. So we say active allowed IPs from game. We're going to turn the allowed IPs into an array. So we'd say allowed IPs array, and we're going to take allowed IPs. We're going to replace space and remove it, and then we're going to join on comma and turn that into an array. IP allowed, and that's going to say, does this contain the source IP? Now that is clearly something we should have sent into this function, which we can easily do now. Same ID, right? So we're saying the IP is allowed if it's in that list. We determine if they have permission, if the game is active, and if the IP is allowed. And we'll send Eternian back. We'll say if you have permission, send the game ID back. If not, send null back. So we're using the require syntax here because it's Node. And another and another thing where I'm acting like I'm in React, right? So we get the game ID. This is the correct value based on this game ID, based on this API key. So let's put that to the test, though. I'm not sure I believe you, Lambda. I'm not sure I believe you. Okay, so we're going to save this and say this is active false. And we'll run it again. Game ID is null. That is exactly what we want. So let's go back in and turn it back to true, which should give us the value, which it does. Let's set it to true, but then we're also going to set this to something other than the IP from which we are hitting it. Also null. Good. That's what we want. Not bad. So it is, that function is doing its job. So let's go back to API scores. We have this. So if game ID is null, we are going to send back with condolences, user, you are not allowed to do this. There's something not right about the request. We don't want to be super forthcoming about what we don't like about the request. So we're going to return the callback. Right? We'll give it a generic 400. We probably could do, or forbidden or something like that. But for now, we can just do 400. And our helpers, we're going to right. So we're gonna have something like that. And we'll just call those our default response headers, just so that we have those that we can send back. And then in the body, we'll say success is false, error is API, let's say API key is missing, like that. I mean, maybe that's not opaque enough. Maybe we want to just say there was an error. I don't know. What do you think? Should add a default, and then we don't do anything in the default. And we'll add some acceptable post and get and some acceptable methods. For example, post get, right? So we're saying if the method is not included in this array of acceptables, then we will dump it out. So that's a way of getting around that. So we don't have to return anything down here and repeat this code if we don't really want to, which I don't really want to. Once we get down to this, we already know that the source IP is correct, that the game exists based on the API key. We also know that the request type is of post or get. We're just going to create a scores array and some query parameters, right? And let's see how we did this before. For games, we pulled that. So let's just take that same and we'll say scores. Index name, because we're looking it up on the game ID index, right? Because we're querying by game ID, and we're going to say scan index forward false. We don't want A to Z. We want Z to A in the sorting. So we want the highest scores first. Now, an area for improvement down the road would be to make this an option in the game object and say, do you want to sort highest to lowest or lowest to highest? Because if this was a golf game, we wouldn't want to score it like that. So key condition expression, we're just going to say game ID equals, I can type game ID, right? And we did that before. Expression attribute values. Basically, we're parameterizing these values to keep everything safe. We're going to say game ID, and replace that with game ID that we pulled from the database in this function up here. So we're going to go up here and just say limit limit equals 25, meaning we're going to pull in 25 every time. We're going to pull in 25 scores. And we'll say limit query page size limit. And that's all we need for now. So you're going to see the next thing we're going to do is related to this last fetch key. Sometimes last fetch key comes across as a string that is null, so we just want to protect against that. So we're saying if it exists and isn't a string called null, a string null, we are going to use that last fetch key as our exclusive start key. Right? So we are passing last fetch key in as a stringified JSON object, because your last fetch key is not just the ID of the item. It's actually a whole object. It's actually X last fetch key. So much like X API key, X last fetch key. So that becomes last fetch key. And then we pull it in here. And we only include the last fetch key if it is passed in. If it's not, then we just start from 0. But if it is passed in, then we only pull new records past that. So that is what we would call load more pagination. Right? Similar to what we did before. And then we'll do then data scores equals data items. So that's what we're going to get back. And then next fetch key is data last evaluated key. And then we also have catch and then we don't need this break because we're going to return the callback and we'll return status code 200. We'll return the default response headers and we will send a body that looks like scores next fetch key. Because I have prettier on, it's going to rearrange everything, but you get the idea. Let's check. So you can see what we've done here. We just need to say opposite, right? So you can see the mistake that I made. We just need to say opposite, right? Yeah, so we have to say let scores equal because later on we're going to say scores equals everything's fine. So it's telling us nothing, and that's fine. That's what we want. We're going to do something that we won't do later on. We're going to create a scores item here. We'll create the score ID and the score. We also need to have game ID. So we're going to throw a temp value in there for now. We'll go into games, test game 1. This is the game ID. We're going to copy that in there. Into the score, game ID. Now I should be able to, there we go. So now let's move on to this next item. And so we are going to pull in some fields from the request body that are going to come from the game. The request body is this. So when it comes across in the event, it's just a string. So we are going to parse that and we are going to destructure our two main things from request body. We're going to create a score ID. And I can hear you saying, wait a minute, we don't need to create a score ID. That's what databases do for us. Not in this case. DynamoDB does not necessarily create an ID for all of the things that you create. We're going to pull in crypto random bytes and then call that random bytes so that we can create things quickly. We need to create a URL string function. So we're going to say const to URL string and so that's what that function does. It just makes this random content into something that is URL safe. And we are going to use that. and then we'll pull it in here. And then we will so we'll create a score ID that's 32 characters, and then we make it URL string friendly. We would also need to check to make sure the name and the score are there. So we would say const valid body equals name, right? We also want to say that. So if score is not a number, then we're not interested. Also name. So we're saying valid means score and name exist. Score is a number and name is longer than 0 characters. We say if it's not, then we're going to return callback. We'll say status code 400, headers, default response headers, body is JSON, stringify, right? Something like that. We have a valid request at this point. So we're going to say const score num, meaning our score as a number, just to confirm that it's a number. We're going to say parse int score. Now, if these are floats, let's say the game is based on times, maybe we should use float. But for right now, we're just going to use ints. But that may be a thing down the road where I want to refactor this to allow for floats, because if you have a timed game, that's a thing. I know that when I built all those Flash games, a lot of them were based on how quickly you can get through a level. So we're going to say await score create, score ID, game ID, name, score num, DDB. Let me put score create up here. I think it makes more sense thematically. Score create equals, right? And then we are going to do that. And then now we have our input. We're just using a simple put in the scores table. So we're going to say, we're going to pull in this table name. We're going to say scores, right? And created at is get current date time. And we'll add that one down here. I don't need to export it. We're just using it here. So get current date time. So we're going to say return DDB put, right? I'm going to say table name. These are the parameters, right? Table name, which will be that. Item. Oh, item. And created at. So that's probably all I need, and then promise. We're going to return a promise. So this will create a score. And we have score create down here, and we bring in score create up here. And there we go. Which we don't need this for because we're doing a return. And we get to do 201, which is always fun. Headers, default response headers, body JSON stringify. We're going to send the score object back. And we don't need the default, but I wonder if we should, just for the sake of completeness, just in case, and we give this an error that doesn't make much sense. Like something went wrong, period. Just to confuse people. So that's all we need to post a score. So it's what, 100 lines? Not too bad. I mean, we've got some helper functions here, but still not too bad. It's very simple. Now, what we're going to do is we're going to take this API key, we are going to pop it over into post score, and we're going to create that API key. We have the name of AAA and a score of 11. So we'll do that. And it didn't like it. So the issue here is that I was using that API key without the dash in it. So we got a body and we look at AAA and score 11. We need to pass stage to the helper function. Not too bad. So we'll just do stage down here, right? And then in the helper function, score create, we'll do stage there. All right. So I just didn't save here. And then once I did that, it created that score. So we can tell by going back to get scores, we should see more than just that one item. We're going to see two. And you'll see that this has more information on it. We're actually going to delete that score because it's just going to get confusing down the road. Delete it. Now you notice that the score wasn't immediately available. And even if I refresh it, it won't show up. It won't show up until I refresh the page. This is something about DynamoDB that you just have to get used to. You think that just hitting that refresh button would refresh the data. That isn't always the case. So now when there we go. It's showing me the correct information. Let's create some more scores. We'll say, let's do that 121, and we'll say that that's me. And we will say, and Will got 446. And so now we go back to get scores, and now we have 3 items, right? And it gives me when they were done, it gives me who did them, it gives me the game ID, all that stuff. Now, let's make sure of some stuff. Let's go into the games and create a score for game 2, right? So we go in, we create in post score, we'll go to headers and we'll change that API key. And we'll say that. So now we can go into get scores and change the API key, and now we'll see just the one, right? So it's working. So it's working in dev. One thing that may be a problem when we go to production on this is that these two names are the same, the logical name and the AWS name. So we're going to change both of them just in case. They were items that were in my VPC at some point in the past. It seems like Serverless was having trouble deploying them in that state. So we're going to push to production. We're going to go SLS deploy, stage, and then prod. It looks like it executed properly. So it gave us pretty much everything we need, including our endpoint. So we're going to go over to the AWS Web Console, and we can see we have not only our dev games and scores, but we also have our prod games and scores. Now, prod has nothing in it, so what we're going to do is kind of copy some of that data over. And I'll go through and add the allowed IPs in here in just a minute, but I don't want you to see that. So we have that. And this value I can change down the road by pulling it and redeploying it. So we can go to prod get scores. So that is going to give us what we want there. And we will grab this API key from before and we'll throw that in there. So that's what we expect because I haven't put my IP address value in there. So you'll have to take my word for it. I added my IP address to the game object under allowed IPs, and now I'm seeing a blank item instead of what I was seeing before, which was, hey, there's a problem with the request. So we'll go to post score, and we'll put the proper value in here, and we will grab the headers, and we'll put XAPI, make sure that there's a separation in there. Let's save both of these just so we don't lose that stuff. And we'll say to and we have a score. Nice. That was not a lot of work. That was pretty easy. So we are posting to production and we are getting scores back. So one of the things we're going to have to fix before we go too much further is you'll notice that this limit is lowercase. It needs to be uppercase because pretty much everything in this list you can see is uppercase. DynamoDB tends to do that with these query parameters. That should have been uppercase, and that will make sure that we're only receiving 25 items per page in our load more pagination. So I'm in the source code for one of the games. This is Figure 5 Frenzy. This was the math game that we were talking about. This is the scores screen. So we're pulling in the scores. We're using the scores array as a use state, and we're also using fetch key as a use state instance. So if we have a fetch key, then we're saying, okay, send that fetch key in the fetch request. But if not, just send null, and that will send you from the beginning the first 25 items. Then we pull it in and we run the then, and we could probably get rid of that. And then we're going to set the scores. Now, there are two different ways we can set the scores. If we're appending those scores, we're loading more scores, then we are going to concatenate those two, right? We're gonna spread them and concatenate them. If not, we're just gonna take those scores and replace the values that were there before. And then we're gonna set that next fetch key. That's really all there is to it. And then when we pull in new scores, we can handle load more, and we get scores append. If we handle refresh click, that's get scores refresh. Here's the game. And you see we load the first 25. And then we load the next 25. And then we load, they're just the 54 scores currently. So that's all there is to it. And we run a similar query on the game over modal that you'll see here in a second because I'm not good at this game. 8 minus 7 is 1, plus 6 plus 1 is 8. So that gets us to 107. We'll quit so we can just put the score in. So that allows us to put score in. Yeah, it's right there. So that's all there is to it. And we can load more, and then now we have 55 scores. Pretty simple, but it works in production. To conclude, this was enormously fun to build, and after checking out several IAC methodologies, I really like serverless and serverless offline for local development. I did find DynamoDB frustrating at times, but it was mainly when I was trying to use it like I would a standard database. I still like it and think it was a great fit for this project, but in spite of it being used in nearly every cloud tutorial on the web, I'd be a little careful about specifying it for smallish projects with a complex schema. Of course, Amplify is another thing you should check out and would probably have made this project easier. That sounds like an excuse for another video. So, what do you think of DynamoDB? Can you think of other use cases for small to medium-sized projects? More importantly, what should I do next? Let's see what the Topic-O-Matic has for us. Test-driven development, theming with Material UI, building a JSON-driven headless CMS for cheapskates. I really like that one. Migrating from React Router DOM v5 to v6, hybrid map routing with Mapbox. How about isometric games in React or 2D games with 3D lighting in Godot? Interesting. Do any of these topics catch your eye? Let me know in the comments. If you want some more detail, there's an article about this project on markmakestuff.com. All right, that's all I got. Bye.